the geometry of the cross product. Okay. So, by definition, vector A cross B is equal to vector C. So the first point I would like to make here is this: cross product of two vectors. Okay, this is a vector. This is a vector. Remember, dot product is equal, this is a number A, so this is a scalar. Okay. Now, cross product is a vector. Now, we suppose to have a vector A, consider vector A and vector B. That is alpha. Now, there is a plane, okay, in which A and B lies on that plane. Let's call plane pi. A and B lies in this plane pi. Now, this straight line here, perpendicular to A and B, this straight line, okay, the vector C will lie in this straight line here. Now, what is the direction by definition of vector C? Okay, you just use the right hand rule. You rotate A from A to B, and this is the direction of vector C. Now, this is direction of vector C. Okay, repeating A and B, that's vector A and vector B. There is a plane in which vector A and vector B lies on this plane. Now, there is a straight line perpendicular to this plane, and the direction of vector C lies in this straight line, in the direction obeys the rule, the right hand rule, A to B is C. Now, what is the magnitude of vector C? By definition, is equal magnitude of vector A times magnitude of vector B times sine of the angle between A and B. That's the magnitude. This is the direction of C. Obviously, B cross A is equal, let's see, B cross A, you just, okay, the direction, it will be the opposite. Why? Because the rule, okay, the right hand rule, you'll be in this direction. Okay, you rotate B from B to A, and the right hand rule will be this. This will be minus C. So B cross A will be minus C. That's important. Now, suppose consider two vectors, A and B, parallel. So there is a plane, okay? Now, the angle between vector A and vector B is alpha is equal to 180 degrees. So the sine of an angle 80 degrees will be 0. So if A and B are parallel, okay, the direction here they have opposite direction, but they could have same direction. Okay, no problem. The angle alpha here will be 0, so sine of 0 will be 0. So if A and B are parallel, okay, then the cross product of these two vectors will be 0. Consider the standard basis. This is x1, x2, x3, E1, E2, and E3. This is orthonormal basis. Now, let's obtain the product E1 cross E1. See? Now, E1 cross E1. Now, the angle between E1 and itself is 0. So, the sine, let's see, the size of E1 cross E1 will be the size of E1 times the size of E1 times the sine of 0. So, this will be 0. Okay? So, the cross product of E1 and E1 is 0, the vector. Attention here, this is scalar, but E1 cross E1 is equal to 0, 0 vector. Okay? This is scalar because it's a magnitude. Now, E1 cross E2. Let's see. E1 and E2. So let's use, that's a plane, okay? E1, E2 lies in x1, x2 plane. So for sure, the cross product will be perpendicular to this plane, okay? According to the geometrical definition of cross product. Now, E1 cross E2. Now we know that E1 cross E2 will be perpendicular to the plane x1, x2. Now, the direction, you just use the right-hand rule. So you move E1 from E1 to E2, you see that you have E3. So this will be E3. Now, obviously, E2 cross E1 will be minus E3, okay? Because E2 cross E1, you just use your right-hand rule, you just rotate, and you'll be minus E3 over here. Now, what is the size, also the magnitude of E3? So, the magnitude of E1 cross E2, this is equal magnitude of E3, which here is the magnitude of E1 times magnitude of E2 plus sine of 90 degrees. Because E1 and E2, you see there's an angle here of 90 degrees. Sine of 90 degrees is 1. So this is 1, this is 1. So the magnitude of E3 is equal magnitude of E1 times the magnitude of E2 times 1. So this will be 1. Okay? Now let's continue. E1 cross E3. Let's see it here. E1 cross E3, you see here that E1 and E3 lies in the plane x1, x3. So the straight line perpendicular to x1, x3 plane is this line here, okay? Now, let's see the direction. E1 cross E3. E1 cross E3 you just use the right hand, you see? So if you move E1 from E1 to E3, you do like that, so this will be minus E2, this minus E2. And obviously E3 cross E1 is equal plus E2. The same procedure we are going to use for E2 cross E3. Now, this is E2, this is E3. Now, you see the plane x2, x3, so the straight line perpendicular to the plane x2, x3 will be in the x1 direction. So, E2 cross E3, you just use the right hand rule, you just move like that. So this will be E1. So this will be E1. Obviously, E3 cross E2 will be minus E1. Okay? Now, this is important because we will use the components of vectors to represent the cross product, okay, of A and B, for instance. Vector A cross vector B. The A cross B in terms of their components. In the standard basis system, okay, in the orthonormal system. This is A, let's put A1, E1, plus A2, E2, plus A3, E3, cross B1, E1, plus B2, E2, plus B3, E3. You see, this we can write 9 components. 9 components, okay? This one will multiply this, this, and this. So it's 3. This one multiply this, this, and this is 6. This one multiply this, this, and this. So it'll be 9 components. Let's do it. This is A1, B1, A1, B1, E1 cross E1, plus A1, B2, A1, B2, E1 cross E2, E1 cross E2. You see, you have to be careful. You cannot put here E2 cross E1. You just the same order, okay? Plus E1, B3, E1 cross E3. Now, this is 3 terms. Plus, now, A2, B1, E2 cross E1. See? E2 cross E1. Plus A2, B2, A2, B2, E2 cross E2. Plus A2, B3, E2 cross E3. Plus now A3, B1, E3 cross E1. Plus A3, B2, A3 cross E2. Plus A3, B3, E3 cross E3. See? As I said before, we have 9 terms. Now, E1 cross E1 is vector 0. Now, E2 cross E2 will be vector 0. And E3 is be vector 0. Now, I'll give you a hint. just for you to figure out quickly. You put here, let's put here, look, E1, E2, E3, E1, E2, and so on. Now, you just look, E1 cross E2 is E3, but E3 cross E2, so when you go forward, it's positive. When you come and this direction here is negative. Okay? For instance, E1 cross E3 is minus E2. E2 cross E1 is minus E3. It's very, very easy to see it. Now, E1 cross E2. E1 cross E2 is E3. Let's I'll try to, this is E3. You see? Now, E1 cross E3. You see, look, E1 cross E3. You are coming backward, okay? That's minus E2. This is minus E2. Just quickly, okay? You see here. Now, this E2 cross E1. E2 cross E1 will be minus E3. Does it see? Minus E3. Here, E2 cross E3. E2 cross E3 is plus E1. This is plus E1. Now, E3 cross E1. E3, attention, E3 cross E1 is plus E2. Here, E3 cross E2, E3 cross E2, you see, E3 cross E2 is minus E1. See? Now, we have E3 here, E3 here, E2 here, and E2 here, E1 and E1. Each couple is plus and minus. Then you can rearrange this like this. This is equal. This is equal this. You see E1 here. You see this is E1 over here. Okay, and the other E1 is right here. So one is minus, okay, the other one is plus. You see E1, you see A2B3 minus A3B2, E1. Now, I'll give you a hint. Suppose I'll write only this and I will erase this, okay? I'm going to write this just looking at this. You see? Look here. You just put 1, 2, 3, 1, 2, 3. Look. Don't look at that. Look at here. After 2 comes 3, okay? It's here. After 3 comes 1. It's here. After 3 comes 1, it's here. After 2 comes 3, it's here. Now, after E1 comes E2. So I wrote this just looking at this. Now let's continue there. Okay, forget that. Okay, forget this term here. Just look at here. Look. After 3 comes 1. It's here. After B1 comes B2. Now, this A1 comes 2, is here. Then 3 comes 1. After E2 comes E3. It's quite easy. If you write down this, okay, you can complete this. Just look, there's a cycle, okay, 1, 2, 3, 1, 2, 3, like here, E1, E2, E3, E1, E2, E3, okay? It's a simple. So, this is a product. If you call this vector as C, this will be C1, C2 and C3. That's my vector, okay? In terms of the components, the orthonormal basis, A1, A2, and A3, B1, B2, and B3 are the components of these vectors according to the standard basis. Somebody, I don't know who, represented the cross product using a determinant of A cross B. Look, the first row, just put the unit vectors. And this row, the components of this vector here at the left will be A1, A2, and A3. And the third row, B1, B2, and B3. Now, from the theory of determinant, we can expand according to one row, one column, and one. So let's choose, obviously, the first row to expand. So here it will be E1. According to the theory of determinant, you just intersect these two lines here, put E1 over there, okay, this will be A2B3 minus A3B2. So A2B3 minus, you see, just cross here, A2B3 minus A3B2. Okay, for us, it's enough. We don't need to look this. You just rotate here. So here plus, now here it will be A3, after 3 it will be B1 minus A1, this is B3, E2 plus here A3, A1, B1, B2 minus, after 1 is 2, after 3 is 1, E3, that's it. You just write the first one, and the other one you complete by what I said, 1, 2, 3, see, 1, 2, 3, 1, 2, 3, and so on. See? It's quite easy. Or if you look at the determinant, no problem. You see? You cross here and cross here, but the position of this element is negative because it's first row, second column. It is. So this is minus, okay? So you multiply this first, okay, and then this one, okay? So if you cross it here, it will be E2. Instead of A1, B3, is B3, B1, right here, see? That's it. And the last one is the first row, third column. 1 plus 3 is 4, so this is plus. You just cross here, it will be A1B2 minus A2B1. A1B2 minus A2B1. It's quite easy and quickly to do this. Okay, this component. Okay. That's my vector C. That's my vector C. Now, this is not definition of cross product. The definition use geometry, as I said initially. Okay? The geometry, A cross B, okay, is a vector which lies perpendicular to a plane, and the direction obey the right-hand rule. That's it. See? Now, you know also from the theory of the determinant, if you exchange one line, one row, or one column like this, if you have, for instance, E1, E2, E3, and here B1, B2, B3, A1, A2, A3. This will be, you exchange this, you change the sign. So this will be minus C. This will be minus C. And another property, suppose A and B are parallel. Okay? So this row here is a constant times this component. Suppose they are parallel. Okay? You have K A1, K A2, K A3. So this is A times K times A. Okay? Obviously this will be 0. Why? Because K is a constant. Okay? The cross product A cross A will be 0. Why? Because the angle between A and itself is 0, so sine of 0 is 0. So this is the determinant, so this will be 0. Okay? This will be 0. Okay? It's the properties of determinant. But as I said, okay, if you have A, for instance, vector A, you give the component 2 minus 1, 0, and vector B is 0, minus 2, and 3. Okay? You have A1, A2, and 3. B1, B2, B3. You just write the determinant, you put E1, E2, E3. Here, we'll put the components here, 2, minus 1, and 0. Okay? Here, you see, just do the determinant. Or you can do quicker doing this. I'll raise it here. Okay? You just put the determinant, okay, and B, and B. Look, this will be quicker. Instead of solving the determinant here, just put here B1, B2, and B3. Just quick. Look, this is equal. Look, this will be, look, A2 B3, A2 B3 minus. Now, you see A3 B2, A3 B2, E1 plus. Here you rotate, okay? This will be A1 B1 minus. I'm sorry, this A3, after 2 is 3. There is A1, B3, E2, plus, now from here, A3 will be A1, B1, B2, minus, A1, A2, B3, B1, E3. You have here, okay, this is A1, this is A2, this is A3, this is B1, this is B2, this is B3. You just plug this number over here and get vector C, just quickly. You see? You don't have to look at this determinant. You just look for the first one. See, you write down and do like this, and write down this. After this, you rotate, okay? Permutation symbol. Okay. This is called also Levi-Civita. Okay? The symbol due to Levi-Civita. Now, you have epsilon I, J, K. You see, this is a third order tensor, okay? The component. Now, this is equal plus 1 or 0 or minus 1. Now, you see, for instance, I want to know is plus or minus 1. First of all, I want to know when it is 0. It will be 0 when I is equal J, or I is equal K, or K is equal J. They could be, all of them could be equal, like this. I is equal J is equal K. Okay? But it's not necessary. Okay? at least one of these two, if they repeat, for instance, epsilon 2, 2, 3 is 0, epsilon 2, 1, 2 is 0, epsilon 1, 1, 3 is 0. This is 0. Now, it will be plus 1. I'll give an example for you to understand, okay, and see quickly if it's plus or minus 1. Suppose I want to know what is 1, 3, 2. 1, 3, 2. Or it will be plus or minus 1. Okay, it's not 0 because I is different from J is different from K. So it's not in this situation. You do like this. You write down here 1, 2, 3. Okay? Here you put 1, 3, and 2. Now you join 2 with 2 and 3 with 3. You have only one intersection. So this is equal to minus 1. See? The number of intersection, the points here, will tell you, okay, if 1, 2, 3, 1, 3, 1 is on the same rotation or not. Now, you see here, you have 1, 2, 3. If you exchange, you put 3 here, you did one inversion. You see this is one inversion, that's why this is negative. Now, look, I'll do like this. I'll make one inversion and other one, okay? 3, 1, 2. I put it here, 3, 1, 2. I always do 1, 2, 3 to compare. Now let's see, look. You see one line here, a straight line here, another one here, and another one there. So 1 and 2. So it's 2 intersections. So this epsilon 3, 1, 2, 3, 1, 2 is plus 1. Always do that. You compare, okay, with 1, 2, 3. Now, it's quite easy to see it. Let's take another one, just randomly, okay? Epsilon 2, 3, 1. Like this. Okay? I don't know yet. Okay? Then I compare 1, 2, 3, 2, 3, 1. 2 here, 1 here, and 3 here. So 2 intersections. So this is plus 1. Okay? Now, suppose I put 1 over here. Okay? 2, 1, 3. 2, 1, 3. I compare 1, 2, 3. Let's put here and here. So, and this does not intersect. This is 1. So, epsilon 2, 1, 3, epsilon 2, 1, 3 will be minus 1. See? It's quite easy and quickly. To represent the cross product between A and B as a vector epsilon ijk aj bk. Now, you see here that epsilon is a third order tensor, aj is a vector, bk is a vector, but this whole term here is a vector. Why? Because j are dummy and k are also dummy indices. Okay? So I is a free index. So this I is free index. Because you have only one, so only one free index, this is a tensor of first order. Okay, tensor of first order. Now, let's develop this according to this definition. So this is equal. Now, I, this is epsilon I. Now, I will sum first on j. Then it will be 1k, A1, BK, plus epsilon I, j now is 2, k, A2, BK, plus epsilon I, in this case it will be 3, k, A3, BK. Now, you see, I'm summing on j, 1, 1, 2, 2, and 3, 3. Now, for each of these three terms, I will add 3 terms using k1, kk2, kk3. Like here, kk11 plus 2, 2 plus 3, 3. Here, 1, 1 plus 2, 2 plus 3, 3. Now, but I will not do that. You see why. Look, you remember that, suppose I have, I will erase here, okay? I will erase here just to have some space, okay? I will erase here too, okay? Look, you remember that I have 1, 2, and 3. Here, 1, and 2, and 3. Now, this, if I go and put 2 here and 3 over there, okay? These 2. Let's see. I will go, let's say, counterclockwise, okay? Like this, and like this. So, if I move counterclockwise, this is plus 1. Now, for 2 to 1, this case, okay, I go here, now I go this way, okay? Look, this, and this. So this is minus 1, like we did before, okay? You see, this 0 here is very important for us to simplify some terms over here. Look, you see this epsilon I1, okay? Now, I cannot be 1. Otherwise, okay, it can, but it will be 0. Okay, for I is equal 1, this term here will be 0. Doesn't matter what k it is. Doesn't matter. So if I is equal 1, for sure this term is 0. Now, for I is equal 1, this can be 1, and this can be 1. So let's write here, okay, I is equal 1. I will not repeat this term here because epsilon 1, 1 will be 0. Then I can write over there epsilon 1, 2, k, A2, BK. Now, plus I1 here, it's okay, epsilon 1, 3, k, A3, BK. Now I see one interesting thing. Now, k cannot be 1, neither 2, okay? Because k has to be 3 here, has to be. Otherwise, if k is different from 3, this term here will be 0. So, for I is equal 1, for sure, k is equal 3. Okay, then here is 3. Now, here, k only cannot be 1, cannot be 3. K here has to be 2 and 2. So for I is equal 1, look, for I is equal 1, I can write epsilon, I'll call, for I is equal 1, I call C1, okay? Do you remember? A cross B is equal C, okay? For I is equal 1, I have C1 is equal. Now, epsilon 1, 2, 3, look, epsilon 1, 2, 3, so this is plus 1. Now, epsilon 1, 3, 2. I just substitute, I just move 3 in the middle here. I made one permutation. For sure, this here is minus 1. So C1 is equal A2 B3 minus A3 B2. A3 B2. You see how it's simple? Now, the same procedure I will choose is a free. I is equal to, okay? Now, you remember one important result. Do you remember when I got C1, okay? C2 will be easy because after 2 is 3, after 3 is 1, after 3 is 1, after 2 is 3. It's 3. See? Like C3, I'll put here, C3 is equal, after 3 comes 1, this is 2, minus A2, B1. See? When I get the first one, I can rotate, okay? I can rotate against C1, C2, C3. Also, it's a good exercise for you, okay? If you plug here I is equal to, and for sure we'll come up with the results from here. If you put here, you choose I is equal 3, you operate here, for sure you're going to get this. So, to represent vector C as a result of A cross B, we use the permutation symbol. That's our message. That's IJK, AJ, BK. One important property is this. Let me show you here. Now, you see, epsilon IJK, if you move K, I, K, J, this is minus epsilon IJK, okay? Because you just move K here in the middle. Now, if you move again, epsilon K, Ij is equal plus epsilon IJK, okay? K, this K here, you move once, and then again. So now you see you change the sign twice. So epsilon Kij is equal to epsilon Ijk. And another very important property, this you should memorize. Okay? You should memorize. You can check. The videos and books, they say they are equal, but I say this identity. Look, epsilon I, JK, epsilon, the same here, I, PQ. You see, look, I here is dummy, okay? This is a fourth order tensor because JK, PQ. Okay, this is a fourth order tensor. This is a fourth order tensor. Why? Because for free indices. You see, what are these free indices? J, K, P, and Q. This is identity. Look, you do like that, you memorize like that. You put delta here, delta in there, minus delta and delta. Now, forget about the I, okay? Now, JP, in this, look, KQ. Now you put minus here. Now you reverse the order. Okay, the first one get the second one here. So JK, and the third one get the second here. KP. Please memorize this because you can check. Okay, look, you make here. J is equal 1, K is equal 2, P something else, and check here, okay? Using the properties or property of the chronic delta, okay? We did this several times, so for sure is this. Now, you could write this, instead of I and I here, you put I here and I here. Doesn't matter because you see, the I is kept once and twice, here and here, so the same thing. I prefer to write the I first. Okay? Now, don't forget, epsilon ijk. Okay, this is a fourth order tensor. Okay? Look, one thing that I didn't emphasize, the number of free indices on the left-hand side must be equal the number of the free indices on the right hand side. And the same notation, for instance, if I have here, look, here I have 4 free indices. You see, here I have 4 free indices, the same here. So the number of free indices on the left hand side must be equal the number of free indices. For instance, if I have A, I, J, K, K is equal B, J, I, M, N. Look, how many free index do I have on the left hand side? 2. IJ. The same IJ has to be on the right hand side. The same number and the same notation. Okay? That's a very important, which we can see here. I here is not, it is not a free index, it's dummy. That's why it didn't appear there. Okay? For instance, I could have here R and R. No problem. R is dummy, no problem. Okay? So R could be 1, 2, 3. In general, write I and I here. Please don't forget this. You just, when you see IJK, I, PQ, repeat 2 delta, put minus here, and then you say the second one, okay, picks the second one here. The third one, the third one there. See, JP, KQ. Put minus. Now you reverse. The second get the third one, and the third one get the second, and put there. Don't forget this, please. Don't forget. But you can't see this identity. Just play with P, Q, J, and K. You see that you come up. The right-hand side is identical to the left-hand side is identical to the right-hand side. Don't forget this, a very important property, and we'll be using this. Okay? We'll use this a lot